Alrighty, so here's a quick poll question. I'd like you to try it yourself first, and then you can watch my explanation. So hopefully you've tried it at this point. There are two total forces that act on the box to the right. Only one is shown. The resultant acceleration of the two forces is also shown, pointing in the third quadrant. If F2 was also shown with the tail of F2 at the origin, in which quadrant would its tip be? So if I have one force pulling this block to the right, and overall I need this block to accelerate down and to the left, what does the second force have to do? Well, first, part of the force needs to counteract the fact that it's being pulled to the right by pulling to the left, and then I needed to add a little bit more because overall the acceleration is to the left. And then we need the force to also pull downward because the overall acceleration is down and to the left. So basically I know that my force needs to point somewhere in this third quadrant in order to pull this block down and to the left. So the only option that works out here is C. Additionally, we know that F2x has to be negative. Basically, things in the third quadrant, x component's negative. And then we know that the y component also has to be negative because things in the third quadrant is that. One other way to approach this is basically if I do sum of the forces, I should get of all the forces, or I shouldn't put net and sum. So sum basically means F net. So if I sum up all the forces, this should equal mass times the acceleration. So the direction of the acceleration vector should be in the direction of the net force vector. So I can check my work by doing the tip to tail sum. So here's F1. Then I said F2 should look like this. So now if I draw the tail of F2 at the tip of F1, it'll look something like that. And then finally my resultant vector, F net, will point like so. And that checks out because my net force and my net acceleration look like they're pointing in the same direction. So we've picked third quadrant.